All right, so today's notes is going to cover 4-6, which is going to be going over isosceles and equilateral triangles. We'll go through this first section kind of quickly since we've already talked about isosceles and equilateral triangles. So first we're looking at isosceles triangles. Please remember that isosceles triangles is going to have two sides that are congruent. These congruent sides will often be referred to as legs. These are your congruent sides. In an isosceles triangle, just to kind of reiterate here, your two congruent sides are referred to as your legs. We also need to remember that in an isosceles triangle, we're going to have two base angles that are congruent. And the location of these base angles are always going to be across your congruent sides. So these base angles will always be across the legs of your isosceles triangle. And those base angles must be congruent if it's isosceles. The last kind of term that you need to be familiar with when it comes to an isosceles triangle is going to be something known as your vertex angle. Right here in green, this vertex angle will be where your two congruent sides meet. So you will need to be familiar with the terminology of legs, vertex angle, and base angles because you're not always going to get a picture. You'll see in one of the examples that you might get a word problem that describes what an isosceles triangle looks like, and it'll be your job to be able to draw it correctly. Okay, so next we're looking at an equilateral triangle. An equilateral triangle is going to have all three sides congruent. So this all three sides are congruent. And remember that our congruent sides are often represented by tick marks, so matching tick marks. One other thing we talked about equilateral triangles was that if it's equilateral, then that means it must also be equiangular. So in this case, if this is equilateral, then it must be equiangular. So all three angles here will also be congruent. And this would be a good time to kind of talk about what the three angles in a triangle add up to. We know that the three angles in a triangle add up to 180, and if each of these are congruent, then we can say 180 divided by 3 would tell us the measure of each individual angle. This is super important, understanding that each angle in an equilateral triangle is 60 degrees. So each of these angles would be 60. Okay. Next, we're going to be looking at some theorems here. So we're going to be looking at something known as the isosceles triangle theorem. All right. So the isosceles triangle theorem kind of says something that we've already talked about before. So the isosceles triangle theorem says that if two legs of a triangle are congruent, then the angles opposite those sides must be congruent. So kind of like what we talked about earlier. Okay. So if I have two congruent legs here, then this is saying that the angles opposite of them must be congruent. Okay, and we've had this conversation before, and we saw that happen in the first day of notes. All right, so I'm going to erase this here because we're going to also be looking at the converse of this isosceles triangle theorem. Remember, the converse of a statement swaps the hypothesis and the conclusion. So instead of saying if two legs of a triangle are congruent, then the angles are opposite are congruent. We're going to swap the order, so we're going to say here if two angles of a triangle are congruent, then that means that the sides opposite those angles must be congruent. So let's kind of see what that looks like in the picture. So if I'm given a triangle here where we see that two angles are congruent, then that would mean that the sides opposite them must be congruent as well. Okay, and here obviously it's marked for you, but what this could potentially look like is if I had a triangle like this. Okay, if I had these base angles that were congruent, two angles that are congruent, then this is saying the sides opposite of them would have to be congruent then, and that would allow us to mark it like this. Okay, then we have something known as the corollary to the base angles theorem. Okay, and this kind of is something we already talked about earlier. So this is going to state that a triangle is equilateral if and only if it is equiangular. Okay, and what we've talked about already before is that if it's equilateral, then it's equiangular, meaning that each angle is going to be congruent, and we already know that each angle is going to have to measure 60 degrees if these three are going to add up to 180. And that's what this last blank is. Each interior angle of an equilateral triangle equals 60 degrees. Okay, what today is going to be about really is just going to be looking at a couple of different examples, and there's honestly a good amount just because there's a lot of different scenarios that we can run into with isosceles and equilateral triangles. So we'll run through these first ones pretty quickly. Example 1 says find them each measure. So if I want to find each measure, it says find YZ. Okay, well this is using the converse of that isosceles triangle theorem, right? Here I see that these base angles are congruent, so that means that the sides that are across from them must also be congruent. So that would mean that this side must be congruent to this side, meaning that YZ here must be 12. Okay, so YZ here is 12. And if we want to put the units here, this would be 12 centimeters. Okay, next we're looking at the measure of angle Y. If I want to find the measure of angle Y here, then we're using the triangle angle sum theorem, understanding that the three angles in a triangle add up to 180. So this would be 77 plus angle Y is equal to 180. Okay, I'm going to work this here going down. So 77 plus 77 is 154. So we got 154 plus angle Y is equal to 180. If I subtract 154 on both sides, what we end up with here is angle Y is equal to 26. So angle Y, the measure of angle Y is 26 degrees. Okay, so please remember when we're looking at angle measures, please make sure that you're putting the degree symbol. Okay, so that's example 1. Next, let's look at example 2. Example 2 says find the measure of angle C and the measure of angle E. Okay, well, the first thing I'm noticing here is that this is an isosceles triangle. If this is an isosceles triangle, these are my legs, my congruent sides. And I know that the angles across from them, which would be angle C and angle E, must be congruent. Okay, so if I don't know what these angles are, I can call angle C X. And because these angles are congruent, if C can be represented by X, then E can also be represented by X. So if I want to find angle C and E, just use the triangle angle sum theorem again. X plus 106 is equal to 180. This gives us 2x is equal to, and I'm skipping some steps here, if I subtract 106, then we have 74. Dividing by 2 on both sides tells us that x is equal to 74 divided by 2 would be 37. So angle C, because it's represented by x, is 37 degrees. Same with angle E. Angle E is represented by x, so it is also 37 degrees. Okay. Next, we're looking at number 3. Number 3, if you take a look at number 3, all three sides are marked congruent, so that means this is going to be an equilateral triangle. Okay, and if this is equilateral, we made the kind of discussion earlier that that would mean it's equiangular as well, that all three angles would be congruent. Okay, so angles J, K, and L, if it's equilateral, we understand that each angle measure is going to be 60 degrees. All right, we'll run through the next example here. It says find the value of each variable. And this is just looking at kind of the same things that we looked at earlier, just now looking at this algebraically. So here I have my congruent sides, my legs. The sides, not the sides, but the angles across from them will be congruent. So the angles that I have marked in blue there have to be congruent. If these angles are congruent, then we say that they're equal. So 5x plus 9 is equal to 8x minus 30. If we solve for x here, subtract 5x on both sides, we get 9 is equal to 3x minus 30. Adding 30 to both sides, we get 39 is equal to 3x. If I divide by 3, we see that x is equal to, this would give us 13. Okay, so really the focus that I'm trying to go through with the notes here is just how to set it up. I know you all know how to solve equations like this. The focus here is just on the setup, which is written there in blue. All right, and then we get to other questions like this that kind of force you to kind of think about what it is to be isosceles. Looking at number 5. This is isosceles. We have our congruent sides marked, which we call the congruent sides in an isosceles our legs. And the angles across from them would be congruent. So these two angles would be congruent. These types of questions sometimes throw people off a little bit because not all three angles are marked, but it's going to be your job to understand that the base angles here at the bottom in blue are congruent. So if this is 6x plus 8 right here, then this is also 6x plus 8. And now you can just do the triangle angle sum theorem again. So setting up our equation here in blue would be adding up all three angles to 180. So this would be 6x plus 8 plus 6x plus 8 plus 80 degrees is equal to 180. Okay, if I combine like terms here, we get 12x. 8 plus 8 is 16. If I add that to 80, it gives me 96. So we got 12x plus 96 is equal to 180. Subtract 96 on both sides. That gives us 12x is equal to 84. If I divide by 12, 84 divided by 12 is going to be 7. So x equals 7. I'm just going to box it over here so it's a little bit easier to read. Okay. Next one we're looking at here is using one of the theorems that we talked about earlier. If I see that these base angles are congruent, then that means that the sides across from them must also be congruent. So in this particular scenario, these two sides must be congruent. Now, if they're congruent, that means that they're equal, so we can write the equation 15x plus 7 is equal to 23x minus 17. Here we subtract 15x. We get 7 is equal to 8x minus 17. If I add 17 on both sides, 7 plus 17 is 24. is equal to 8x. Dividing both sides by 8, we get 3 is equal to x. So x equals 3. Okay, I am going through the solving part of this. I'm trying to go through it pretty quickly because, again, we should be familiar with this. But if you need to pause the video or slow down, if you want to work it out on your own, please feel free to do so with any of the examples that we do here. Okay. Next, we're looking at triangle PQR. If triangle PQR is an equilateral triangle, solve for x and y. So you'll notice that here in the problem, it actually tells you it's equilateral. Okay, nothing in that triangle is marked. So it's important that you're actually reading the questions. I'm super guilty of this. I don't always read. I just look at the picture and try to start. Read the question. A lot of the times there's useful information in there. So if this is equilateral, we can understand that that means that each side must be congruent. Okay, and that would also mean that each angle must be congruent if it's equilateral, right? So with each angle being congruent, we understand that each angle is going to measure 60 degrees. And we can actually start with that. Take a look here. This angle is 60 degrees, and it's represented by 7x minus 3. So I can write an equation that says that. If I have two expressions representing the same thing, then that means that 7x minus 3 must give me, or must be equal to 60. So we just solve for x. Add 3 to both sides. We get 7x is equal to 63. From here, we divide by 7, and we get x is equal to 9. Okay, so the question asks you to solve for x. We did that. We just have to solve for y now. Okay, what you'll notice here is that you have 3 congruent sides. Okay, when you set this up, I think the first time we had a problem like this in the first day of notes, somebody asked me, do I put all 3 sides equal to each other? No. Okay, you just pick 2 sides. Okay, doesn't matter what 2 sides you pick, as long as you solve correctly, you should get the same answer. So I'm going to choose the sides that I feel like are probably easier to work with. I'm going to choose the 11y minus 23 and the 9y plus 1. So our equation would say that those 2 sides are congruent or equal to each other. So 11y minus 23 has to be equal to 9y plus 1. From here, if I solve, then we're looking at subtracting 9y on both sides. This would give me 2y minus 23 is equal to positive 1. Add 23 on both sides. We get 2y is equal to 24. If I divide both sides by 2, that means y is equal to 12. And that checks off everything that they asked for. We solved x, we solved for y. Okay, so those are kind of the easier questions that we're looking at, but that kind of serves as our foundation for isosceles and equilateral triangles. What we'll look at here kind of is some slightly more challenging problems. So if I look at example 8, it says find the values of x and y in the diagram. Okay, and nothing is really stated. It doesn't tell you it's isosceles, it doesn't tell you it's equilateral. It's your job to figure out what is going on here. Okay, so the first thing I want to bring your attention to is look at these angles that I'm marking in red. These 3 angles all have one ring, so that means that all 3 angles are congruent. If all 3 angles are congruent, that's indirectly telling me that we have an equilateral triangle. So that would mean that these 3, and let me actually do this in a different color, that would mean that these 3 sides of that triangle on the left must be congruent. Okay, so it said solve for x and y in the diagram. Well, if this side right here is represented by 7 and it's congruent to this bottom side, then that means x must also be 7. This would imply x has to be 7. Okay, what you have to do now is find y. Okay, and as you do these pictures, whenever there's kind of more than one triangle in the diagram at a time, kind of think of it as a puzzle. The more pieces you fill in, the easier it's going to be to kind of see what's going on. So if this side here is 7, that means this side here is 7 and this side is 7. Okay, what I also want to bring your attention to here now is this. Take a look at these base angles that were marked congruent. What I'm looking at currently is going to be this triangle on the right. If those base angles are congruent, then that means that the sides opposite of them must be congruent as well. Okay, so that would mean that the side opposite of that, this one, and this side must be congruent. So notice that that's already marked with a single tick mark. That would mean that this side is congruent to that side we labeled as 7. So this would just be setting up an equation saying y plus 4 equals 7. If I subtract 4 on both sides, we get y is equal to 3. So that one wasn't so bad, but again, it's kind of just slowly transitioning you into that kind of more complex diagrams that we look at here. Let's look at example 9, okay? I know it's like a lot of examples that we're going through, but I think we just have 9 and 10 and then we're done here. So if we look at example 9, okay, they do kind of tell us some useful information in the text. So it says triangle ABF is isosceles. triangle CDF is equilateral, and the measure of angle AFD is 150. Find each measure. So I'm going to go ahead and start marking the information that was provided. Triangle ABF, isosceles. So ABF, they were nice enough to mark that for you. What they didn't mark, though, is that the base angles are congruent. So I'm going to mark that in the picture just so that we don't forget. Next, it says that triangle CDF is equilateral. Okay. Well, if CDF is equilateral, we know two things. We know that all three sides are congruent, and if it's equilateral, we also understand that each angle measure is going to be 60 degrees. So this is 60. This is 60. And this is 60, okay? You want to fill out as much information as you possibly can. And then they're also telling you that the measure of angle AFD, okay, and I'm going to do this in a highlighter because we got some overlapping going on here. So AFD is 150. AFD is this angle right here, okay? So from here to here, it's 150. I'm trying to write that a little nicer here. So it's 150 from there to there, okay? So, and we're asked to kind of find each missing angle here. What I'm going to do here is I'm just going to go ham on the picture. If I look here and look at the 150 here, I see that the 150 is composed of these three angles, right? So that means that those three angles, when I add them up, must add up to 150. So I'm going to go ahead and look at the expression here. This angle right here with the red dot is going to be called angle AFB. So angle AFB plus the 35 degrees, which is this angle, plus the 60 degrees, this angle, has to add up and equal to 150 because that is the angle AFD. So here we just solve for angle AFB. So 35 plus 60 would give me 95. So angle AFB plus 95 is equal to 150. If I subtract 95 on both sides, that'll tell us that the measure of angle AFB is equal to, well, 150 minus 95 is 55. So that would mean that this missing angle right here is 55 degrees. Okay, and because we marked in the first triangle on the very left, triangle ABF, we know it's isosceles because of the two sides that were marked congruent. We marked the base angles congruent, so that would mean this angle over here to the left would also be 55. Okay, and you'll start to see that the puzzle kind of slowly starts to come together here. So if I know that the base angles are 55, okay, I'm not going to waste y'all's time with an equation. We know that these three angles that I'm going to highlight in yellow add up to 180. So this plus that top angle adds up to 180, okay? 55 plus 55 is 110. If I subtract that from 180, then I know that the top angle is going to be 70. So that top angle there is 70, okay? And we can go ahead, I know we've kind of filled out a lot of information here. Let's go ahead and start looking at what they asked us to find. So let's see if we've answered some of these here. So here they're asking you in the first problem, the measure of angle CFD. Here's C to F to D. That angle, we already marked it earlier. We understood that that was 60 degrees. So that's 60 degrees. Next, they asked us about angle AFB. That's the one that we actually found with the equation down there at the bottom in red. AFB would be from A to F to B. It's that angle, 55 degrees. Then we have angle ABF, which happens to be that top angle. So from A to B to F, it's that top angle, which we actually found already, is 70. So 70 degrees. And then they're asking you for the measure of angle A, which is this angle right here, 55 degrees. So we've pretty much answered all the questions here. Could I fill out more information in the picture? Sure, but for time's sake, we're going to keep going. The only kind of easy one that I'm going to fill out here just really quickly is that this angle right here would be 30 degrees, right? Look at the blue highlighted part. If that's 150, then it would form a linear pair with the 30 degrees. All right, but let's go ahead and finish up here with the last example. And this is what I was talking about earlier in the notes. Like, they're not always going to give you a picture. They might give you a verbal description. So example 10 says triangle JKL is isosceles with base angles at K and L. JL is 5 more than 2 times a number. JK is 3 less than the square of the number. KL is 1 less than the number. Find the length of the legs and the base of triangle JKL. So just by reading this, we can already kind of understand that this one is probably like a lot more challenging than the ones that we looked at in the notes. So why don't we just start by chunking this up, okay? I want you to look at the first sentence, okay? Triangle JKL is isosceles. So we know we're going to have two congruent sides and two congruent base angles. They're telling you right here that the base angles are K and L. So when I draw this triangle, I know it's isosceles. I know that I'm going to have these congruent base angles and these two congruent sides. And they tell you that the base angles have to be angle K and L. So I know K has to be here, L has to be here. That would mean that in triangle JKL, the J must be at the top, which J represents the vertex angle here. So here they're kind of giving us some information here about, in the next sentence, now it's saying that JL is 5 more than 2 times a number, okay? The issue here is I don't know what that number is, okay? If I don't know what that number is, we can always represent that by X. So this, when you have these word problems, I always recommend translating it. 5 more than translates to plus 5. 2 times a number, well, we said the number is represented by X, so this would be 2X. So when you translate it, we can understand now that JL can be represented by the expression 2X plus 5. If I look at the next part, and I'm doing this in highlighters to kind of get you to see like how you should be chunking this. The next part is talking about JK. So JK is less than the square of the number. 3 less than the square of the number. Okay, so square of the number, that would be X squared. Okay, 3 less than would be minus 3. So let's put it together here. If I'm looking at JK, then if I have minus 3 and X squared, this can be represented by X squared minus 3. And so that part's huge in understanding how to represent JL and JK. Now that I have the picture, I can label the picture. JL is 2X plus 5. JK is X squared minus 3. Well, these represent our legs, our congruent sides of the isosceles triangle. That means that these two must be congruent or equal to each other. So I can write an equation that says that. We have X squared minus 3 would have to be equal to 2X plus 5. Okay. What I have here is an equation with an X squared and an X and a constant. This is kind of already an indicator that we're probably looking at factoring here. So if I want to solve this by factoring, you need this equation to be equal to 0. So that's going to be our focus here. I need this to be equal to 0, so I'm going to move the 2X to the other side. This would give us X squared minus 2X minus 3 is equal to 5. Now we want to move the 5 over because I need this to be equal to 0. So minus 5 on both sides would tell us that we get X squared minus 2X. Negative 3 minus 5 is negative 8. And now this is equal to 0. Okay. When you're factoring, okay, by now we should be pretty comfortable with factoring. What I'm looking at here is if I'm looking at the X method, known as the AC method, at the top, A times C would give me negative 8. At the bottom, we have our B term, negative 2. So what numbers multiply to give me the top? Well, I need a positive and a negative to multiply to get a negative. Okay. The numbers that are going to work for us here is I'm going to need a positive 2 and a negative 4. 2 times negative 4 gives me negative 8, and when I add these up, it gives me the bottom of negative 2. So this represents my factors. Okay, when there is no number in front of X squared, this straight up is just your factors. This only works, though, when there is no number in front of X squared. So our factors here are going to be X plus 2 and X minus 4, and that's equal to 0. Okay, the question here was asking you, well, the last part, I guess we didn't fully read this. I just got carried away here. But it says KL is 1 less than the number. So this would mean that KL equals 1 less than the number would be minus 1. So this would be X minus 1. So KL is X minus 1. I just forgot to label that. At the very end, it's asking you find the length of the legs and the base of triangle JKL. So for me to be able to find that, we're focusing our attention on finding the value of X. So the idea here is this. Please do not get in the habit of just thinking it's always opposite signs. That doesn't always work 100% of the time. Take the time to actually set each factor equal to 0 and then solve for X. In this particular scenario, it does end up being the opposite sign, but that doesn't always work, especially when there's a number in front of X squared. So our values for X that we got is negative 2 and positive 4. Well, how do I know which one to use? Okay. The reason why I know which one to use is, well, you plug them both in and test to see, does it work for all sides? So if I plug in negative 2 here, negative 2 squared is positive 4 minus 3. That gives me positive 1. Okay, that's a reasonable length for a side. 2 times negative 2 here would be negative 4 plus 5. That gives me positive 1. That checks out. If I plug it down here at the bottom, though, negative 2 minus 1 is negative 3. I cannot have a side length that's negative. So our x value of negative 2 does not work here. We call that an extraneous solution. So let's test out the 4. Okay, if the negative 2 doesn't work, that kind of is an indicator that the 4 has got to be the one that works here. Okay, we should be pretty good at doing mental math here. If I do jk, x squared minus 3, this would be 4 squared minus 3. 4 squared is 16, and if I subtract 3, it's 13. So jk is 13. JL, which happens to be the congruent side to that, should also be 13. Let's test it out. This would be 2 times 4 plus 5. 2 times 4 is 8. If I add 5 to that, it's 13, so it does check out. And then lastly, if I look at KL, KL is represented by x minus 1. Well, x is 4, so 4 minus 1 tells us KL is equal to 3. So that represents all 3 sides of our isosceles triangle, which was asked in the question there at the very end. Find the length of the legs and the base. We've done that, and that'll be the end of our notes. Okay.